Hi, seventh graders. I hope you're having a good week.
Here's our third online lesson on probability. We're going to start by just talking about probability in general. So what is the probability of getting tails when you flip a coin? So there are two sides on the coin, and one of those two sides is tails. What that is right there is called the theoretical probability. It's like a theory. It's what should happen. It's what we think would happen. But there's something called experimental probability, and that's what's actually going to happen. So is it possible that I could get 10 heads in a row? Yeah, it is. It's just not likely. That's not what we'd expect. We'd expect if we did 10 of them, if we tossed 10 times, we would expect tails 5 of those 10 times. But it is quite possible that we could have 10 out of 10. So Beth tosses a coin 10 times and records her results. Here are the results for the 10 tosses. So if you are looking at this first row, she got heads. So it's a 100% chance that she's got heads so far. Second time, she also got heads. That's still a 100% chance. But now she's got tails. And now if you do that, 1 out of the 3 or 2 out of the 3 is 67%. Okay, and then we could keep going here. And you're going to notice that the percentages keep changing, and they're never really 50%. It's going to keep going up and down based on how many she has. Here's a little graph of that information. Now, please notice that we're getting closer and closer to what we expect, which is that 50% right there. These ones are way up too high. This one's actually a little bit low. But we're going to keep going up and down and balancing on here until we get pretty close to that 50%. So some people, like us, who had a lot of time on their hands, the French naturalist Count Buffon from 1707 tossed a coin 4,040 times, and he got heads 2,048 times out of that. So that is very close to 50%. Please notice that it's not perfect. He got 50.69%, and that's out of 4,000 tosses. Next, around 1900, the English statistician Karl Pearson tossed a coin 24,000 times. He got heads 12,012 times, and that comes out to that, which is getting even closer. That's 50.05%. Now, it's never going to be perfectly 50%. That is what we propose and what the theory says, but that's not a guarantee. And lastly here, while imprisoned by the Germans during World War II, the South African mathematician John Kersh tossed a coin 10,000 times. He got heads 5,067 of those. So likewise, that is not a perfect, it's really close, 50.67%. So that's the difference between theoretical probability, which is what we talk about most of the time, and experimental, or what actually happens. Okay, what we're going to talk today that I'd like you to be able to do is multiple events. What's the probability that a family with 3 children will have 3 girls? If you watched the last video on the tree diagrams, you should already know the answer to this question, but we are going to do it with a calculation. So there are 3 events. So what I'm going to do is I'm going to draw 3 lines. 1, 2, 3. We would like girls on each of these. So I find that it's helpful to label so I know what I'm looking for, and then that'll be our answer. And what we're going to do is figure out the probability for each of these events individually, and then we're going to multiply those together. So what's the chance that the first child will be a girl? It's 1 out of 2. What's the chance the next one will be a girl? Just looking at that one, not looking at anything else, just that one is 1 out of 2. The third child is also a 1 out of 2 chance. So if I multiply, I'm going straight across, I'm going 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8. So there is a 1/8 chance that a family with 3 children will have 3 girls. Remember, please, that P in front tells you what's the probability of rolling a 2 and flipping heads. So that's 2 events. So I'm going to do 2 lines. The first one is roll a 2, and the second one is that I'd like to flip a coin and get heads. So I'm going to multiply these 2 together, and that will give me my answer. So what's the chance that I'm going to roll a 2 on a die? Okay, so there is one side that has a 2, and there are 6 sides, so it's 1 out of 6. What's the chance I'm going to get heads when I flip a coin? That is one side out of the 2 sides. So I'm going to multiply going straight across. 1 times 1 is 1, 6 times 2 is 12. So those two events together have a 1/12 possibility. I'm going to flip heads 5 times in a row. So that's 5 events. So 1, 2, 3, 4, 5. I would like to get heads on each one of these. I'm going to be multiplying them together and getting my answer. So the chance of heads is 1 out of 2. And that is the chance for each of these. Like this 5th one here, it doesn't know that it's had heads 4 times in a row. So it's not going to be like, oh, you've already had heads 4 times in a row. Next time I think I'm going to be tails. It is still a 1 out of 2 chance. Multiplying going straight across is 1 times 1 times 1 times 1 times 1 is 1. 2 times 2 is 4, times 2 is 8, times 2 is 16, times 2 is 32. I'm going to write it down here for a little clarity. So you've got 1 out of 32 chance of getting heads 5 times in a row. So it's not impossible, but it's definitely unlikely. Okay, what's the chance, the probability of rolling a 5 and a 4? So a 5 and a 4. I'm going to multiply those together. The chance that I'm going to roll a 5 on a die is 1 out of the 6 sides. And then on the second one is also 1 out of 6. Multiplying those together gives me 1 out of 36. Now, I've got the second one that looks very similar, but you should notice the difference here is the and the or. So what's the probability? A 5 or a 4. How many things am I actually doing? I'm just doing one, and that is a 5 or a 4. So how many sides of the die have a 5 or a 4? That is 2 of the sides out of the 6. And there's nothing to multiply by, so it's a 2 out of 6 chance. So you have a much better chance of rolling a 5 or a 4 on one roll than rolling a 5 and a 4 on 2 rolls. So that difference of the and the or. There's another thing we need to talk about here. So what's the chance of picking a queen and then a king with replacement? So that's 2 events. I'm going to multiply them. I'm looking for a queen and a king. What's the chance that I'm going to get a queen? There are 4 queens out of the 52 cards. And this with replacement here means that once I get that queen and I'm holding on to her, I'm actually going to replace her back in the deck. So there are still 52 cards in that deck, and how many of them are a king? 4 out of the 52. So I'm going to multiply and get 16 on the top. And offhand, I don't have my calculator here to do the 52 times 52. So that will go on the bottom there. Now, the second one, I'm going to pick a queen and then a king without replacement. So I'm doing 2 events still. I still want the queen. I still want the king. But this time, I am not putting it back in. So when I get the queen, there are 4 queens out of 52 cards. But now I'm going to set her down right over here. And she is no longer in the deck. So now how many kings are there? There are still 4 kings. But how many cards are there? There are now only 51 cards because this queen is sitting over here. And then we'd multiply that, so 4 times 4 is 16. And this time, please notice it's 52 times 51, which is going to be a slightly smaller number. I have a bag here. The bag has 3 white, 3 black, and 4 spiral marbles there. Okay, so what's the chance of picking 3 black marbles without replacement? So here's 1, 2, 3. I'm going to multiply it together to get my answer, and I'm looking for black each time. So how many blacks are there to start here? There are 3 blacks out of, how many are in that bag? It looks like there are 10, but I am not without replacement. So I've just taken one of those marbles out. So that one isn't there anymore. So now how many blacks are there? Well, now there's only 2 because I have this one over here that I'm holding on to already. So there's only 2 left. And how many marbles are there? There are now 9 marbles in the bag. So this marble is going to sit over here. and it is not in the bag anymore. So now for the last one, I've got one black marble left. And how many marbles are there left? 1, 2, 3, 4, 5, 6, 7, 8. Okay, so I'm going to multiply those together. 3 times 2 is 6, times 1 is still 6. 10 times 9 is 90, times 8 is 720. So there's a 6 out of 720 chance that we're going to get all 3 black marbles if we don't replace them. Down here, what's the probability of 1 black, 1 white, 1 striped again without replacement? So we've got 3 things we're trying to get. We're trying to get a black, we're trying to get a white, and we're trying to get a striped. Okay, so let's erase these markings from the bag. The chance of a black was 3 marbles out of the 10, but now I've got that black one sitting over here, and so it is not in the bag anymore. So how many whites are there? There are 3 white marbles, but there are only 9 because this black one's over here, and now a white one's sitting there, and that white one's not in the bag anymore. How many striped are there? There are 4 stripes, and once I get that in there, it is not in the bag anymore. Oh, I'm sorry, we don't have to do that. Never mind. We're counting how many are left after those 2. There's 8. Multiplying across, 3 times 3 is 9. 9 times 4 is 36. 10 times 9 times 8 is 720. So please notice you've got a better chance of getting 1 black, 1 white, 1 striped than getting all of the blacks out of there. That should make sense to you if you think about it. We have a spinner. We have a red sections, yellow, green, and blue. Let's take a second and count how many, starting from the yellows. We've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So our fractions are going to be out of 12. I would like to spin 3 reds, so that is 3 events. Red, red, and red. The chance of the first red, there are 1, 2, 3, 4, 5. There are 5 reds out of the 12. But now please notice it doesn't say anything about with replacement or and or, because the spinner, you can't take it off. I just got a red, but it's not like that red is gone now. That red is still in play for the next one, so it's still 5 out of 12. And the next one is still 5 out of 12. And then I'm going to multiply those across. I know 5 times 5 times 5 is 125, but unfortunately without a calculator, I don't offhand know 12 times 12 times 12. What is the chance of spinning 1 blue, 1 red, and 1 yellow? So I've got 3 events. I'm going to multiply them. I'm looking for a blue, a red, and a yellow. So the chance of a blue, there are 3 blues out of the 12. Chance of a red, there were 5 reds out of the 12, and a chance of a yellow is 1 out of the 12. Multiplying straight across, again, I don't know that bottom one, but 15 on the top. Okay, so I'm going to give you a homework here. Homework 5.5 is practice on this part of it, the multiplying events. So please, step 1 is to list out how many you've got. So like in this case, we did 3. I strongly encourage you to label them, blue, red, and yellow, and then go through, get your fractions, and then multiply them and get your answer over here.